Hi all, my name is Kevin, and in today's video we are going to be learning the arithmetic sequence and series. So basically in question 2 we have given the arithmetic series 18, 24, 30 plus plus all the way to 300. 300 is our last term, we're going to call it L, and 18 is our first term. So basically how the arithmetic series work is we have a couple of numbers. Say we are given a number, first number, and then plus the second number will be the first number plus the difference. So basically it will be a plus the difference, where the difference is the first difference between these two numbers. So the third number will be the second number plus the difference plus the difference. In other words, we're going to have a plus 2d all the way up to the last term, which will be a plus n minus 1g. What does that mean? So as you can see, this is our first term, we'll call it T1. This is our second term, we'll call it T2. This is term number 3. As you can see, when we are on 2, D value is 1. When we are on 3, D value is 2. When we are on 4 or on term number 4, D value will be 3. So basically it's always 1 less. That's why our last term would usually have a plus into n minus 1 multiplied by d, where d is our common difference. So d is basically the difference between these two terms. Okay, so the way we do this question is first we have to check the difference between these two numbers, which will be 24 minus 18, which will give us 6, and then 30 minus 24, which will give us 6. So by reading this statement, you can see that this series is arithmetic, and then we know by first common difference being the same. In other words, if I have to add 6 to 36, I know the fourth term will be 36. Rather, if I have to add 6 to 30, I know the fourth term will be 36, and so on. But because we have large number, like we have a lot of numbers to add to until we get to 300, we have to look for a general formula which we can use to find any number within this range. So we will not be doing it manually. Had I given you 1 plus 2 plus 3 plus all the way to 5, it was going to be easy because you know the second term that's following is going to be 4, and then you know the difference is 1, 1. So you're going to add 1 to 3 and then you get a 4 all the way to 5. You know that as long as the difference is common, then you are done. But because there's a lot of numbers that are omitted here, we need to use a general formula so that you can be able to sum all of these numbers up. Remember, a series is about summation, so we have to know what is the total sum of all of these numbers, including the ones that are omitted here. So now the first question says determine the number of terms in this series. When they're looking for the number of terms, they are looking for 1, 2, 3, and including all of the omitted numbers and 300. So to determine the number of terms, we're going to be using the formula that's like Tn is equal to, remember, Tn is our generic formula, or is our general formula. So we know that our general formula Tn is defined as a plus n minus 1d, and then Tn is also our last term, so it's going to be 300, and then we know that our first term is 18 plus n minus 1 and our difference is 6, then we'll get 300. So multiplying 6 into n, we get 18 plus 6n minus 6 is equal to 300. 18 minus 6, we are going to get 12. 6n is equal to 300 minus 12. And we know that 300 minus 12 is going to give us 6n is equal to 288. All of these numbers divided by 6. We are looking for n, number of terms. So n is going to be equal to 288 divided by, if this 6 divided by 2 is going to be 3. 288 divided by 2 is going to give us 144. So I'll use my calculator. 288 divided by 6 will give me 48. So the number of terms are 48. Alright, so this is for question number 2.2.1. Now calculate the sum of this series. The sum of this series, to calculate it, we use the formula that's given in our examination sheet or our formula sheet. So the sum of this series, since it's arithmetic, we're going to use Sn is equal to n over 2 into a plus l. Remember, l is the last term, a is the first term. This is a plus sign, this is the number of terms, and this is 2. Okay, So we're going to say 48 divided by 2 into 18 plus 300. 48 divided by 2 is equal to 24 into 318. I'll erase this part. Now I get 24 multiplied by 318. I get 7632. So all of these numbers, including the ones that are omitted, they add up to 7,332, rather 7,632. Okay, this is question number 2.1.2. Now, question 2.1.3 says, calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6. Okay, so this is a rather very important question. Remember, the one that we calculated here is divisible by 6. So the ones that are not divisible by 6 will start from up to and including 300 that are not divisible by 6. So we will have 18, 19. 18 is divisible by 6. So we will not count 18. Our sequence will look something like, or rather our series will look something like 18, 19, 20 plus 21, so on until 300. Now, observe very clearly that our sequence will be 19, 20, 21 plus other numbers, but they should not be divisible by 6. And if you can check here, the numbers have to be whole numbers, which we have alluded here, and then the difference, we're going to have 1 here. So the difference between these two, all of these numbers is 1, and they must include 300 and must not be divisible by 6. But we know that 300 is divisible by 6. So our last term will not be 300. In fact, it will be 299. I'll confirm if 300 is divisible by 6 for you. So 300 is divisible by 6, so we will not include 300. It will end at 299, which will constitute our last term. So basically what they're looking for is the sum of all numbers that are not divisible by 6, and they start from 18 up until 300. But remember, 18 and 300 are divisible by 6, so we will not count 18. So everything else should remain the same. I'll show you the other way to do it without using the method that I'm using now. Alright, so let's start. Okay. Alright, so the next thing to do is we have the difference here. We know that our sum will be number of terms over 2. The first term is 19 plus last term is 299. And then now we don't know our n. Remember, we cannot use the n that we calculated previously, which is 48, because we are not including 18 and 300 and other terms that are not divisible by 6. So basically how we'll do it is we're gonna look for our number of terms, which will be Tn is equal to 299 is equal to first term is 19 plus n minus 1, difference is 1. So we have 299 minus 19, which is n minus 1. 299 minus 19, we have this minus 9 will give us 290. So we have 289 plus 1 is equal to n. 289 plus 1 will give us 290 is equal to n. So the number of terms that we'll have is 290, which can be concerning because here we had 48. But remember, here the numbers were divisible by 6. So our terms here will be 290. All divided by 2, 299 plus 19, 318, and we can have 318 multiplied by, or rather let's have 290 divided by 2, 145 multiplied by 318, which will give us 46,110, which is the sum of all numbers not divisible by 6, and that start from 19 up to 299. Remember, 300 is divisible by 6 and 18 is divisible by 6, so we won't start at 18. So if I did the math correctly, I should get 46,110. Okay, let's try another method to see if our answers check. Alright, so we're looking for sum of all the whole numbers that are not divisible by 6, and initially we had the sum of all numbers divisible by 6, which was this one we calculated here, which gave us 24 by 318, which was 7,632. But now we can use another method that's going to help us as well. Now we are looking for the sum of all numbers within this series. So we're going to have 18 plus 19 plus 20 up until 300. Okay, so sum of all numbers will be ST, which I'll call sum of total numbers, and then the number of terms, which will be n. So the number of terms will be calculated the same way. So we will use 300. I'll use a different marker, which will be 300 is equal to the first term is 18 plus n minus 1 multiplied by the difference of 1. So 300 minus 18 is going to be 282